So the last last ion sources I will define in this lecture is the MALDI source, which is the matrix-assisted laser desorption ionization. I decided to show you the four major sources in mass spectrometry, but there is also other sources in the literature. However, these four sources are the major source used today. So the MALDI, everything is in the name of this source. This is an acronym of Matrix Assisted Laser Desorption Ionization. So we are going to perform the aim of the source, which is the volatilization and the ionization of the compound. In that case, this is simultaneously, because this is a desorption ionization using a matrix which assists the desorption and ionization by the use of a laser. Okay, now I am going to explain you. The MALDI is based on the use of a compound, which is named the matrix, that absorbed at a wavelength of a laser. The wavelength is classically 337 nanometers. Then you have a compound which has the properties to absorb this wavelength. And then if they absorb this wavelength, they have energy, and the energy will be transferred to the sample by the matrix. That's the principle of the ionization. And then this ionized sample will be transferred after ionization to the analyzer. One of the major and important things to know about matrix is the fact that in that case, we generate ions at a single charge. This is not as ESIMS, where it is possible to see multi-charge ion. In that case, we generate ions at a single charge. So how it works, and here you have the representation of the MALDI-MS. You have here a plate related in the cathode, and here a plate related in the anode. You have on this plate the mixture of a matrix and the sample. Then you have here in blue the matrix, which is a compound who absorb the wavelength of a laser. And in yellow you have your compound, and you see that there are a lot of matrix for a small quantity of compound. Okay, this system is solid. It means that you have a totally desolvated system, and this is a crystallized system. Okay, the mixture matrix sample is solid. After that, you applied the a laser, and then you see here that you have, of course, a hole in your sample. And because you have a matrix who absorb the wavelength of the laser, you obtain the ionization, the ionized matrix. The ionized matrix is obtained because they absorb the energy, the wavelength of the laser. And due to the fact that there are a lot of matrix as compared to the small quantity of sample, by transfer of energy between the matrix to the sample, you perform the ionization of the sample. Then this is a two-step process. First, we hit the sample with the laser. The matrix take the energy and then become ionized. And after that, by transfer of energy between the matrix and the sample, you obtain ionized sample. This is also the desorption phenomena, meaning that here you have a solid phase, and because you have the heating of by the laser, you obtain a gaseous phase here. After that, you perform the analyze of your molecules, because here you have all the ionized molecules, and after that you need to perform the analysis of the molecules in the analyzer. So here you have a lot of funnel to extract, to accelerate, and to focalize the molecules, and after that to go to analyzer. So, as I told you, the sample and the mixture between the matrix and the sample is solid. Then you need to spot the sample in a multi-target plate. Here you have the classical multi-target plate for a manufacturer, which is ABSIX, but there is other manufacturer with different geometry. However, the system are always similar. Here you have different places to perform your spot. You see here, you have different places, 1, 2, 3, 4, 5. It is possible to make all the number of position you can spot your compound. And to spot the compound, you perform a deposit of your compound of around 1 microliter. So here you have the sample preparation in MALDI MS. Generally, we perform a mixture of a sample and a matrix. The matrix is a compound, the small molecules who absorb the wavelength of the laser. Generally, you need to perform protonation. Then you perform this in water, 0.1% trifluoroacetic acid, and acetonitrile 50-50 to allow the volatilization. And here you have your sample in the same condition of the matrix. So the matrix here are the alpha-cyano 4-hydroxycinnamic acid, which is a classical matrix using for small molecules. You have here then the mixture, for example, 1 microliter of the sample plus 1 microliter of matrix, and then on the target, directly on the target, you perform the mixture of these two compounds. The analyte is diluted about 1,000 times, 10,000 times in the matrix. Then you understand that you have a lot of matrix as compared to your compound, and this allows the ionization, this facilitate the ionization of your compound. This is slow and total evaporation of solvent process. Then you have the formation of a large matrix crystals, and this system at the end is solid. We never perform MALDI on a liquid compound. This is always on a matrix, on a solid compound, a crystallized compound. And of course, if I am solid, it is not possible to perform coupling with liquid chromatography or gas chromatography. So that's a drawback of the system. So what is the characteristics of the matrix? We use a matrix with low molecular weight. Indeed, we have to facilitate vaporization, which is one of the aim of this of the source, and then the low molecular weight matrix are an advantage to facilitate vaporization. We use the acidic properties of the matrix because in that case we generally perform the ionization in positive mode using a protonation. Then this acidic matrix acts as a source of protons to allow the detection of MH+. We also have a strong adsorption in UV. That's the major point of the matrix, of course, because they need to absorb the laser irradiation to allow the ionization of the matrix, and then to allow the ionization of our sample. And the functionalization, these compounds are generally functionalized with a polar group because generally we work in an aqueous solution or an organic solution, and then we need to have polar group to allow the dissolution of our compound in the aqueous solution. And then the role of the matrix is very important. There is two different roles. The first role is to protect the analyte from destruction by a direct laser beam. Of course, you can maybe imagine that it is also possible to perform the ionization of the compound directly using the laser. So in that case, it is possible. In that case, it is named LDE. So the laser desorption ionization, and you need to be sure that the compound absorb in UV and absorb the laser irradiation. That's the obligation of this to obtain an ionization. However, the major issue, if you perform this, is the energy of the laser, and sometimes you fragmentate your compound. If you perform this with a matrix, you protect the analyte, you protect your compound from the destruction, and then you perform the ionization in two steps. First, the ionization of the matrix and the transfer of energy to the sample. And the second role is to facilitate its vaporization and ionization. This is the role of the matrix, the major role of the matrix, of course, to allow the aim of the source, which is vaporization and ionization. So here you have different type of matrix. The most common matrices used in MALDI-MS. I just show you this. This is of course just an informative slide, but they absorb at 337 nanometers and crystallized easily, which is two important properties when you use a matrix. So classically we use the dihydroxybenzoic acid or the alpha hydroxycinnamic acid or the synapinic acid. These three matrix are the main matrix used in MALDI. If you see the literature, you will see that it is always with these three kind of matrix.